Hello, welcome to the OpenAdmin Tool Compression and Storage Space Optimization demo. In this demo, we will show how you can use OpenAdmin Tool to optimize your storage space usage through actions such as compress, repack, shrink, and defragment. To manage the storage space on your database server, expand Space Administration on the menu and click Storage. On the storage page, use the Tables and Indexes panel to monitor and optimize the space usage for tables, indexes, and fragments. On this page, you can examine the current space usage for all of the tables, indexes, and fragments in a particular database. The grid shows you the number of rows, the number of extents, the space usage, the compression status, the used size, and the page usage for each object. The space usage column gives you a graphical indication of the space allocated to each table and index. The green color indicates free space, the red plus the pink equals the current used space, and the pink is an estimate of how much space could be saved through compression. This column makes it very easy to determine if any of your tables or indexes could benefit from compression. The space usage and page usage data is not generated in real time, but instead is cached in the sysadmin database and updated via a scheduler task. If you want to manually refresh this data, use the Update Information action to force the space usage and page usage data to be re-evaluated and updated. Let's update the information for all of the tables and indexes in this database now. To perform any space optimization actions, you first select the desired tables, indexes, or fragments, and then click on the Optimize Space action. Note that my largest table, Table 4, has a current use size of almost 93 MB. We'll compare this number later after we've compressed the table. You can run any of the optimized space actions on multiple objects simultaneously, which we'll do here. For fragmented tables, you can choose if you want to run the optimized space actions on the entire table or only certain fragments within the table. Now that I've selected all of the tables and fragments that I want to optimize, I go to the Action menu and click on Optimize Space. Use the Optimize Space pop-up to perform the compress, uncompress, repack, shrink, and defragment actions in OAT. The compress, repack, and shrink actions for tables and fragments requires Informix version 1150XE4. The defragment action requires Informix 1170, and the compress action for indexes requires Informix 1210. Compressing data in tables, indexes, and fragments can reduce the amount of disk space used. But besides saving storage space, data compression can also have performance benefits since there will be fewer page reads and reduced I/O activity as more rows can fit on a page, since more data is stored in the buffer pool, and since you'll be saving on logical log usage, which can prevent bottlenecks for high throughput OLTP workloads. For Informix version 1210, if any of your selected tables include simple large objects, text or byte data types that are stored in the DB space, you can choose whether or not you want the simple large objects to also be compressed. The repack action allows you to consolidate free space in tables, fragments, and indexes. The shrink action allows you to return the free space to the DB space, thereby reducing the total size of the table or fragment. Finally, the defragment action allows you to merge non-contiguous extents. Defragmenting a table improves performance by bringing data rows closer together and avoiding partition header page overflow problems. Defragmenting an index brings the entries closer together, which improves the speed at which table information is accessed. All of these actions can be performed individually, or you can execute them all at once using one single action in OAT, as we'll do here. Our space optimization task was created successfully by OAT. This task will run in the background on the database server. To see the results of any task, you can go to the Task Status tab, which we'll look at later. But we can also see the results reflected here in the grid. You'll notice that the compressed column now has green check marks for all the tables that I chose to compress. You'll also notice that the table named Table 4 now has a used size of 18 MB. This is a significant savings from my original used size of nearly 93 MB. You can also see here the result of the fragmented table, where I chose to only compress 2 out of the 3 fragments. You'll see that the third fragment is still uncompressed, and I could achieve further space savings and further reduce the number of used pages by compressing this last fragment. Starting with Informix version 12.10, you can also compress indexes. You'll notice that I have an index named Table 7 IDX that can achieve significant savings from compression. Let's compress that index now. You can see here that my Table 7 index is now compressed. Note that you can also compress indexes at index creation time, which you can do in OAT in the Create Index wizard in Schema Manager. In Informix version 12.10, there is also a new feature called auto compression. To compress a table or fragment, that table or fragment must have at least 2,000 rows. To compress an index, the index must have at least 2,000 unique keys. Tables, fragments, or indexes that don't meet that threshold cannot be compressed. However, in Informix version 12.10, you can mark a table or index for compression before you reach that minimum threshold. So you effectively turn on auto compression. Then as data is inserted, that table, index, or fragment will be automatically compressed once it reaches the threshold of 2,000 rows or 2,000 unique keys. Let's try this now. You'll notice that Table 6 only has 110 rows, so it doesn't yet have the 2,000 rows needed in order to be compressed. But I can mark this table for auto compression, and I do that by running the compress action in OAT. Notice that in the compressed column, we now have a green checkmark icon with a clock for this table. That icon indicates that this table has auto compression turned on. So the table is not compressed yet, but as data is inserted and it reaches the minimum threshold of 2,000 rows, this table will be automatically compressed by the database server. Automatic compression saves the DBA a step because they no longer need to come in after data is inserted and run the compress action. Note that you can turn on auto compression at table creation time. This is available in OAT in the Create Table wizard, which is part of Schema Manager. Now let's check out the Task Status tab. This is where you can see the status and results of all the commands that have been executed from this page. Here you can see the result of my command to compress Table 6, which resulted in automatic compression being set. You see some tasks for estimating compression, a defragment task, an index compression task, etc. Finally, there is a tab called Server Optimization Policies. Use this page to configure the database server to automatically optimize the space in your tables and fragments using a scheduled task in the database scheduler. You can enable or disable the scheduler task that compresses, repacks, shrinks, and defragments tables automatically. You can update the thresholds for each of these operations or disable any one of them. You can also configure when the scheduler task runs. This concludes our demo. In this demo, you have seen how you can use the Tables and Indexes panel and the Space Administration Storage page to monitor and optimize space for tables, indexes, and fragments. Thank you.